Here in section 5.7, we're going to start learning to use factoring to actually do things. In particular, we're going to learn to use factoring to solve equations. We're not going to start off with equations, though. We're going to start off with a little mental exercise to focus you on a key idea that you probably already know, but you haven't really put into words yet. The example is to imagine some sort of a guessing game, where you're guessing one of the two numbers that I have in my mind, and the hint that I'm giving you is what their product comes out to be. So if I tell you that I'm thinking of two numbers, and when I multiply the numbers together, my answer comes out to be 20, there's a lot of different things that you might guess for what one of those two numbers is. You might guess that one of the two numbers is 2. And the reason you might think that is you're imagining that to produce 20, perhaps what I did was I did 2 times 10, and that produced 20. And that's not a terrible guess. That could work. 2 times 10 does in fact equal 20, but it's not certain to work. I mean, there are other things that make 20. It could have been 1 times 20. That also equals 20, doesn't it? Or it could be 4 times 5, and that could also equal 20. So guessing in this case is not a guaranteed win. But imagine that we were looking at product equals 7. Do you think your chances of guessing are a little better here? Do you think maybe you might guess that one of the numbers is 7? And what you're thinking there is, well, 7. 7's a prime number. The only way to produce 7 is 1 times 7. I've got to be right. If I say one of those two numbers is 7, how could I be wrong? Well, unfortunately, what if the two numbers I was thinking of were -1 and -7? Yeah, that's right. Negatives are possible. Look at the directions. Does it say positive numbers only? Couldn't they be negative? And just to make it really clear how bad the news is here, it could also be 1/2 times 14. There's no reason they couldn't be fractions. Why not? Well, fractions are perfectly legal. And to really be really bad, it could be the square root of 7 times the square root of 7. They can even be irrational numbers. So really, although you thought that product equals 7 was better than product equals 20, it's not actually any better. It's just as bad. There are way too many possible products for your guess to be confident. But then consider this situation here. What if I tell you I'm thinking of two numbers, and when I multiply the two numbers together, my answer comes out to be 0? Don't you have a pretty good guess that you can make here? If you're not sure what to guess, maybe pause the video for a second and think about it, and then press play again. Aren't you guaranteed to succeed if you guess 0? Because think about it. If you were to say, okay, one of the two numbers is 0, and I came back and told you, no, you're wrong, neither one of these numbers is 0, wouldn't you call me a cheater? Isn't it impossible for two non-zero numbers, when you multiply them, to produce 0 for the answer? So you kind of already know that. What you didn't know is that that has a name. That's called the principle of zero products. The principle of zero products says this thing that you already know, that it says if a product equals 0, like in this case that we've been talking about here, then one of the two numbers has to be 0. Here's how that is useful to us. Think about an equation like this one. It's a product. Now, it's a product of x minus 5 and x plus 3, but it's a product. Two things are being multiplied together. And when you're done multiplying, the answer is supposed to come out equal to 0. Well, because of this principle of zero products thing, that tells us that either x minus 5 has to equal 0, or x plus 3 has to equal 0. That's what the principle of zero product says. If you have a product equals 0, one part's got to be 0 or the other part's got to be 0. So what that means is that one equation really breaks down into two smaller equations. And those are much smaller equations. So those equations are really simple. This first one here, x minus 5 equals 0. You just add 5 to both sides and you get x equals 5. Second one over here, x plus 3 equals 0. You just subtract 3 on both sides. You get x equals negative 3. So there are two possible answers to this equation. If x equals 5, the equation gets solved. In fact, you can check it. Plug in 5, and you'll have 0 times 8 equals 0. And that checks. But if x equals negative 3, that also checks. If you plug x equals negative 3 back in, you'll get negative 8 times 0, and that also equals 0. So those two numbers do check. When you have two answers to an equation like this, the way we write them is usually together with a comma in between. So if you see something written like this, or if you write something like this yourself, what it means is x is either equal to 5 or it's equal to negative 3. Those are the two possible values that would work. The real challenge here in section 5.7 is that quite often your equations actually look more like this one. They don't start out written as a product of two things equal to 0. But then that's what we've been learning up till now in chapter 5, is how to take something that is not written as a product and break it up so that it is written as a product. So most of the material we've been learning in chapter 5 has been about breaking up something like this into, well, let's see, in this case, 21, probably 7 and 3, x plus 7, x minus 3, and making this problem into something where the principle of zero products can apply. So if we now have a product equal to 0, then either this part equals 0 or this part equals 0, and each one of those is fairly easy to solve. Move the 7 over here, you get x equals negative 7. Move the 3 over here, you get x equals 3. So the two answers to this equation are x equals negative 7 and x equals positive 3. And don't forget to check. It's fairly easy to check here. You plug in negative 7 and see if it comes out equal to 0. Let's see, negative 7 squared is 49. 4 times negative 7 is negative 28. 49 minus these two, those two add up to 49, so yep, that checks. And the other one, oops, I scrolled too far. There we go. 3 squared plus 4 times 3 minus 21. 3 squared is 9. 4 times 3 is 12. 9 plus 12 is 21 minus 21 equals 0. So they do check. Make sure you continue on to the second video for section 5.7 because there are several challenging, tricky situations I want to make sure you're prepared for. This finishes the basic idea for 5.7. The second video will show you the tricky problems that you need to avoid.